Hi, today I'm going to talk about the logic or the math behind the Sankey diagram. So after I create a video for how to create a Sankey diagram in Tableau. I got a lot of questions regarding some detail adjustment or some issue in when people are building the Sankey diagram. So today I'm going to talk about the, the, the methodology or for so that you guys can understand the logic or the math behind the Sankey diagram. So I will skip. I will pretend that you all know how to create a Sankey diagram. So now I'm just going to talk about how what the Tableau is actually doing in the background for the calculation and what each of the calculated field is actually doing uh, when developing the Sankey diagram step by step. So I have all the diagrams created, and then I have this final Sankey diagram, which I'm not making it like a final product, but it's just like a so as you can see that the shape and then the dot, the connection. If you change it to line, and then you can see that this is the Sankey diagram, and then you can drag the size as size to the you can create a size based on your measure, and then you can change the width for each line. And then as you can see that there's some tilting here when you create the Sankey diagram. I will also talk about that later. What does that means mathematically? Okay, so first of all, I think okay. So I got many questions about whether you need to duplicate or not to duplicate the data set. So as you can see here, I didn't duplicate the data set, but whether it depends on your needs. So if you need to allow filter to adjust, or if you need to apply filter to your graph, then some of the filter may require um, you to duplicate the data and then to make some calculation to connect the parameter as a filter. But since a Sankey diagram is using a table calculation, so there are some restriction or limitation for directly using the filter. So that's why you need to duplicate the data set and then connect to the parameter in order to filter for dimensions here. Okay, so that is that. And so first of all, you need to create um, you need to partition. You need to create a partition for your dataset. So here you always need to use a level of detail to find the minimum of order date for your not order date, but just to find the minimum of something within your the category you want to use. So here region will be my left hand side, and category will be my right hand side for my Sankey diagram. So if you don't understand, please refer to my previous video about how to create a Sankey diagram first. And this video is only going to talk about the logic or the math behind it. Okay, so so whenever I have so now for each region and category, I'm separate separate the data into two different sections. One is 1 and one is 49. The number chosen here is to make to make the curve very smooth. So 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 you can see that here when I choose 1 to 49, you can see that this a curve. Otherwise, if you choose a smaller number or a smaller number, you will see a zigzagging behavior in the line. So okay, so after I create the partition, I also create a bin. So that bin will actually cut my interval from 1 to 49, as that is my calculation for this 2-pad, and I create a bin for this 2-pad, and then so that when I drag it to the column, it will automatically break down to 1 to 49. And don't forget to click on the here, show missing value. Otherwise, you will only see 1 or 49. We will not see whatever in the middle. And then you create a calculation called t. So let me check. Also, t is index minus 25 divided by 4. Okay, so after you create a partition, so let's say 1 to 49. So for each number within this table, since index is a table calculation, so for each partition, so let's say here, you can see that the to bin is equal to 1. So 1 minus 25, it is negative 24, divided by 4 is negative 6. So for your first bin, you will get a t value, not that t value, but this t value equal to negative 6. So your maximum is 49. So 49 minus 25 is 24, divided by 4 should be 6. So you can see that t along 2-pad bin is 6. So whatever in between, you can see that slightly increasing trend. So you can see that if you use 2 minus 25 and then divided by 4, you get that negative 5.75. So so that interval and that index transformation will give you something like this. So your scale for your t should be negative 6, and then all the way to positive 6, all the way slightly increasing a little bit, since your index is 1 to 49, and then as the number increase for the bin, so you divide it, minus 25 divided by 4 will also have a showing an increasing trend. Okay, so that's your first calculated field, and then you also have a sigmoid function here. So the sigmoid function is just the logistic regression. So basically, so as you should all know that so it is just 1 divided by 1 plus exponential of negative t. So that is just a very simple logistic regression with only one variable here. So and as so regression logistic regression is basically converting whatever number you have into the interval between 0 and 1. So as you can see that you input the number, a range of number from negative 6 to 6 with a slight increment, and then when you project or when you transfer this number here using a logistic regression, your final projection will be something like this, something like a cumulative probability distribution. So something like this. So basically you're just mapping negative 6 to 6 into a range from 0 to 1. So in logistic regression, this is just mapping numbers to between probability, since the max probability, the integral of probability should be 1. But in here, we are just, what we actually need is just the curve for that is similar to sigmoid. So there's nothing too mathematical related. So we instead we only want this curvature here. So that's why we apply the sigmoid function here to convert a straight line into a curve that is similar to the sigmoid function here. Okay, so that's the first two calculation, t and sigmoid. And then I think you will create a rank 1 and rank 2, which is based on which they are identical. So basically just the running sum of cells divided by total sum of cells. The calculation, the aggregation formula here will base on what you choose. So here I'm just using the sum of cells. Okay, so okay, one more thing. So when you create the sum of cells, you can see that this is also a table calculation. So you can define your calculation here, but it will, so but it would be better to define the details when you actually creating the graph. Okay, so for sum of cells, okay, so let's say so now I'm looking for okay, so after you create the rank 1 and rank 2, you will also create a curve. So let me just show you about the calculated field first, and then I'll talk about this. So you can see that this is rank 1 plus the difference between rank 2 and rank 1. So basically this is just a difference, and then you multiply by sigmoid function. So basically you are just mapping a number here into a sigmoid function, so that the final result of this curve will just give you a curvature like this, that is transfer from the distance between rank 1 and rank 2. So now I'm going to talk about what exactly is rank 1 and rank 2. Okay, so as you can see here, so now let's say, so now you can ignore the right hand side. So now in this view, I have the sum of cells breakdown by region first and category. So as you may all notice that in the Sankey diagrams in my previous video, so when you do the table calculation for rank 1, you put the region and you put the region first and then the category. When you put when you work on the rank 2, you put the category first and then the region second. So in fact, actually what's calculated behind Tableau is that Tableau will break down sum of cells by region first, as you selected in your table calculation, and then by the category. And then for rank 1, which is basically a running sum divided by the total sum. So the running sum will be the sum that is started from your first row here, since it's a table calculation. So for so the running sum for central furniture will be this, but the running sum of the second line will be the sum of these two, and then the running sum for the third line will be the sum of these three. That is the running sum. So as you can as and okay, and then you also, so for rank 1 you are also dividing by the total sum here. So the running sum will be the cumulative sum in this column, but the total of the sum of cells will always be the total sum of cells, regardless how you apply the filters. So that will be the total sum, something like this. So the total sum will be 2 million, about 2 million. So that will be the total sum for your entire data set. And then you use the cumulative sum divided by the total sum, and then you will get a decimal point here. So that so based on how you drill down the data, so whether central divided by central first, region first or category first and region, you will get a different cumulative sum based on the order for your each row, and you will also get a different number for your rank 1 and rank 2. So although the sum of cells for whether for the furniture for the central region in furniture, or the furniture category in central region, they will be identical for the sum of cells. But when you do the running sum of cells divided by the total sum of cells, the number will be different for each row, since you are doing the cumulative sum. So with different order, the cumulative for each row will be different. Okay, so again here, so that is the raw data part. So now let's take a look for the actual rank 1 and rank 2. So as you may notice that there's a breakdown here. So what exactly is what the breakdown here is doing is because so as you may remember, when you do the table calculation in the Sankey diagram, you have to break down, you have to click the table calculation I can show you here. So when you do edit calculation, you have to do you have to click a specific dimension and then click region first, category, and toolpath, the bin. You have to also click this when you create the actual diagram. So, but here I'm only showing the I'm trying to explain how Tableau is calculated. So when you included the bin, so don't forget. So let's recall that when you create the bin, you break down the data set by either 1 or 49. So actually, that is so there are two sections in your partition. So as you can hover over, you can see that here the third line, the bin is actually saying this is 49, and when you hover over here, so you can see that that is actually 1. So for each region and category, you break down so you create a two different partition for this specific combination. So as you may remember that when you do the two path, you fix the dimension here. So for each region and category, you look for the minimum order days. So for each region and category, you break down either 1 or 49. So that is similar here. For each region or category, you break down either 49 or 1 here. Okay, so that will later on explain why there is a tilting here. So as you can see that when I hover, well, it's not here. Oh, okay. So when you hover over here, you can see that these are all numbers below 48 up to 48. So when the tilting happens, it is because this is actually the 49 partition in your dataset. So for 49 partition, there's always a different calculation here, since you break down this into 1 and 49. But when you actually creating the Sankey diagram, we ignore this part, or we cover, or we use the range to cover this part. So when you cover this, you can see a very a perfect Sankey diagrams to the right hand side, which is actually you using the partition equal to 1, and then remove the partition equal 49. Okay, so that's the reason for tilting. That's because the partition equal 49. And also so now let's talk about the curve function calculated field. So when you hover over, you will notice that the rank 1 and rank 2 will always be a fixed number. However, the curve will always change. That's the reason, because the curve is actually you're actually applying a sigmoid function here, or a sigmoid transformation. So as you notice, rank 1, rank 2, they are always a fixed number. So basically you're using a number, adding a distance between these two numbers, and then you apply sigmoid. So now let's so the curve, so that the curve and then the tilting is explained by this multiplied by the sigmoid function, and only looking at the partition equal to 1. So now let's talk about the rank 1 and rank 2. So let me randomly choose a line. Okay, so just for example, here you can see that the category is office supply and the region is west. And then you can see that the rank 1 is 0.79 and the rank 2 is even 0.53 for the partition equal to 1. Okay, so let's remember that 0.79, 0.53 office supply west. Okay, so now let's take a look at, okay, rank 1 is 0.79. Okay, so for I forget again. So for office supply and west, here. Okay, so for partition equal to 1, okay, here you can see that this number is 0.79. So that number is calculated from this number here. First, you partition by either 1 or 49, so you will get two numbers here. If you do the partition, if you apply the filter here again. and then you use that number, which is and then for all of them do the partition of 1 and 49, and then do the cumulative sum for all the sum of cells, that is partition on 1, all the way from the first row all the way to, let's say in our example is up to this second last, and then you get a cumulative sum, and then you use that number divided by the total sum. So this is the calculated formula for rank 1. And then so basically you're just using a cumulative sum of cells divided by total sum of cells. So of course you will get a number that is between 0 and 1. So for partition equal to 1, you get a 0.7942. Okay, so now let's take a look at the office supply west. So you can see that when you do the different partition, you will get different order for the sum of cells. So that's why the cumulative sum will always be different. And then for partition 1, you get 0.53. So that's 0.54. And here is 79. Okay, so now let's take a look here. Okay, so you can see that that's the rank 2 is 0.54, and then the rank 1 is 0.79. So this so all the dots here, it's calculated from the difference. Actually, the rank 1 plus the difference between rank 2 and rank 1, and then you get that number multiplied by the sigmoid function, which the purpose is that we want to get this a smooth curve here. So that's how the Tableau actually calculating the curvature here, and then actually it is the coordinate for each dot along the partition from 1 to 49, where we later transfer to -6 to 6, and we transfer the sum of cells, the cumulative sum of cells divided by the total sum of cells, into a range from 0 to 1. So that's how the Tableau, that's the logic or the math that is behind this Sankey diagram when you do the table calculation. So personally, I think table calculation is very important when you are doing advanced graph in Tableau. So make sure you understand the table calculation and then understand how Tableau is actually doing the coordinate, the layering, and also the path when you do the line, and this one will also control how the line is actually pointing from starting to the ending location. So this is the logic behind the Sankey diagram. So I hope you can understand it after watching this video. So thank you very much, and please subscribe, share, and let me know if you have any questions. Thank you very much.